A good day to you, ladies and gentlemen, guys and gents, and ladies and guys and girls. Okay. Kumlani here once more, the online math tutor. Thanks for coming to watch this video. Today we're going to be talking about circle theorems and circle geometry. Okay. This is one of the topics that is least taught and sometimes looked down upon, but is very useful in application when you take your studies further, in case you want to become a pilot, in case you want to work in the military, radar, radiation, in case you want to study physics, and many other engineering courses. Okay, let's talk about basic introduction. What is a circle? Okay, so I'm going to be dictating these short notes that I have for you. Then we'll get into the rigorous mathematics after the introduction. In geometry, a circle is a closed curve formed by a set of points on a plane that are the same distance from its center O. That distance from the center to the circumference is known as the radius of the circle. Okay, so here is a short diagram illustrating basically what a circle looks like and its parts. So you got the circumference, which is going from point around the circle back to the initial point. Okay, and the diameter from the circumference through the center to the other side of the circumference. Okay, and usually the center of the circle is labeled as center O. Okay, O standing for origin. Okay, then you've got the radius from the center to the circumference. You've got the chord which cuts across right there, and you've got a sector, which is basically a slice of the circle. Okay, and an arc, which is a part of the circumference. Okay, so here's a description of the parts of the circle. Okay, so it's basically in detail describing everything that's in the previous page. Okay, right, so there we go. In geometry, a circle is a closed curve formed by a set of points on a plane that are the same distance from its center O. That distance from the center to the circumference is known as the radius of the circle. And the diameter, let's say the diameter of a circle, is a line segment that passes through the center of the circle and has its end points on the circle. All diameters of the same circle have the same length. Okay. Then you got the definition for a chord. A chord is a line segment with both endpoints on the circle. The diameter is a special chord that passes through the center of the circle. The diameter will be the longest chord in the circle. Okay, then you got the description of the radius. The radius of a circle is a line segment from the center of the circle to a point on the circle. Okay, the plural of radius is radii or radii. Okay, depending on where you come from. The radii of a circle are all the same length. The radius is half the length of the diameter. Okay, that's great. Now we move on to a tangent. A tangent is a line that touches a circle at only one point. A tangent is perpendicular to the radius at the point of contact. The point of tangency is where the tangent line touches the circle. Okay, then you got a circumference definition there. The circumference of a circle is the total length around the circle. In other words, it's the perimeter of the circle. Okay, then you got a bonus definition that you can take home with you guys. Concentric circles are two circles that have the same center but have different radii. Okay, so you can think of the donut. Okay, one of the circles is the inner circle, and the other circle is the outer circle. So that's a concentric circle. Okay, now that you have the basic definitions for parts of a circle, okay, you have to know what these are, okay, and be able to identify them on a chart or on a diagram. Okay, right, let's talk about the circle theorems. In circle geometry, there are 7 circle theorems that you're expected to know at ordinary level. That's entry-level mathematics or middle school maths. The order with which you remember them is your preference. Okay, let's start by looking at the first one. Angles in the same segment are equal. So we've got the segment there. These angles, x is equal to that angle, x is equal to that angle, x. So that's the first theorem you can take note of. A second theorem, the angle at the center of a circle is twice the angle at the circumference. Okay, so that's the angle at the center of the circle, and that's the angle at the circumference. So that is x, that is 2x. Okay, and you have to make sure the angles are all subtended by the same arcs. Okay, so meaning going from there to there and back, and from there to there and back, it's on the same arc. Okay, all right, let's move on to the next theorems. Angles in a quadrilateral theorem and angles in alternate segment theorem. Okay, the first one says on the page, the angles in opposite segments are supplementary. That's in cyclic quadrilateral. So meaning that angle and that angle, they add up to 180. That's what supplementary means. That angle and that angle add up to 180. They are opposite sides. Okay, they are on opposite sides of the quadrilateral. Take note, this is not on the opposite side as this one. Okay, this is opposite to that one. Okay, this angle follows that one. That angle is opposite to that one. That angle is opposite to that one. Okay, and the next theorem, angles in alternate segments are equal. Okay, so the angles in pink are equal. That angle is equal to that angle. That angle is equal to that angle. Angles in alternate segments are equal. Okay, so we've looked at 4 so far. Let's move on to the next 2. The angle between a tangent and the radius is 90 degrees. And the next one, angles in a semicircle is 90 degrees. Meaning if you have a triangle enclosed in the semicircle there, that angle is 90 degrees. Okay, then the last theorem that we look at, again, is a tangent theorem. It says the lengths between where 2 tangents to a circle meet, which is there, and where they touch the circle are the same. Meaning going from P to T is equal to going from P to Q for a circle radius R. Okay, so those are the 7 theorems that you need to take to heart if you are writing your ordinary level examinations and advanced level examinations, middle school mathematics. Okay, when we talk about ordinary level and advanced level, we're talking of the British curriculum, guys. Okay, if you're in the United States, I think it's some high school mathematics, probably junior high school, okay, or middle high school. Okay, take note, even if you're at degree level, the same theorems apply. Even if you're studying geometry for your Air Force courses, the same theorems apply. Okay, so please revise them over and over until they stick. With those theorems, you're able to tackle any circle geometry problem, from entry-level mathematics to ordinary level mathematics. Okay, you can use the same theorems even if you're in PhD mathematics. Okay, so as a study, let's look at an example question from Cambridge 2018 paper 1 question. It was question 25 and it was only 4 marks. Okay, here we go. It says in the diagram, the points A, B, and C and D lie on the circle. There they are, A, B, C, and D, with center O. TA and TB are tangents touching the circle at A, TA and TB, and B respectively. There is your B. Angle AOB, which is AOB, is 132 degrees. Angle ACD is 59 degrees. Angle AOC is a straight line. Okay, so already you can see there's a triangle in the semicircle there, ACD, before you even start working. But the question says part A, and may I say A, B, C, and D are 1 mark each, so there are 4 marks in total. Find angle ATB. ATB is that angle right there. Okay. Part B, find angle BDA. BDA is there. BDA, excuse me, that angle right there. BDC, that's part C, that's BDC, is that angle right there. Finally, angle OBD. OBD is that angle right there. Okay, that will be 4 marks for you guys. Okay, so using the previous theorems that we've been looking at, you can try and attempt the questions. Okay, remember there are 7 theorems. 2, 4, 5, there's the other 2, 6, 7. Okay, so there are 7 theorems that you can use. Okay, this is to say any question you come across, you can use any of the theorems. It's not to mean that every question you have to use all 7 theorems. Okay, it all depends with the question and how they put it across to you. You can use some or all of the theorems, okay, and other theorems that you learn in mathematics, okay, like how to solve equations, how to deal with quadrilaterals, okay, angles in quadrilaterals. Okay, right, so let's move on. Okay, that's your diagram there. You can try to work it out, and then you can pause the video. Okay, then when you work it out, you can then compare solutions with me. Okay, right, here we go. Here's the solutions. Part A. So for part A, okay, we want to calculate angle ATB, that one. Okay, in the theorem that we use, we said opposite angles in a quadrilateral add up to 180 degrees. Hence, angle ATB is equal to 180 minus 132, which is 48 degrees. Okay, so that's your angle ATB. 180 minus 132, because these 2 angles add up to 180 degrees. Okay, right, so the answer is 48 degrees. That will be 1 mark. Okay, part B. The final answer in part B is BDA is 66 degrees. BDA is 66 degrees. How did we get that? We say the thought process, right? Angle at the center of the circle is twice the circumference. Okay, we use that theorem which says angle at the center of the circle is twice the angle at the circumference. Okay, so that angle will be twice, okay, that angle. Okay, that's your angle BDA. Okay, that's straightforward. I hope you're following, guys. And the next part says we should calculate angle BDC, and the thought process we said angle BAC and angle BDC are subtended by the same arc. Okay, hence they're equal. Angle BAC and BDC, BAC and BDC are subtended by the same arc, hence they're equal. Okay. To calculate BAC, okay, to calculate BAC, I think we've jumped to the next step right there. A BDC. Okay. So the next thing that we did is calculate BAC for us to get BDC. Okay, we're on the right track. So to calculate BAC, notice that BO is equal to AO, which is the radius. BO is equal to AO, which is the radius. Hence, the triangle AOB is an isosceles triangle. So AOB is an isosceles triangle. So what does that mean if it's an isosceles triangle? It means this angle OAB and ABO are equal. Okay, so then we said angles in a triangle add up to 180 degrees. Hence, angle BAC is equal to 180 minus 132 divided by 2. Angle BAC is 180. Okay, since we got a triangle BAO, it's 180 minus 132. Okay, we'll get the total angles in that triangle. We divided it by 2 because remember we said it's an isosceles. So this little angle BAO or BAC is equal to this little angle OBA. Okay, so when you work that out, guys, okay, you should end up with angle BDC is 24 degrees. Okay, so BDC, which is equal to BAC, is equal to 24 degrees. Okay, so that will be 3 marks, guys. I hope that you're following. If there is anywhere where you're stuck or where you're not following, okay, go back to the theorems, okay, and you can try to work it out. Okay. If you're still failing to work it out, you can contact me, hit me up, and then I'll explain it to you. Okay. Right, part D. View the next slide and use the theorem for angles in alternate segment to solve it. So for the final part, which says find angle OBD, which is that little angle there. Okay, I did some labeling on my diagram. I added some angles, okay, and I put a dotted line there so that you can understand how to apply the theorems. Okay, so I put a dotted line there so that I can come up with something like that. Okay, so that I can then apply this theorem which says angles in alternate segment are equal. Okay, so there is the triangle there that looks similar to that one, and there are the 2 angles which look the same, that one and that one. That one and that one correspond to that one and that one. Okay, that's what we used to finally come up with angle OBD, which is OBD. Okay, OBD. So what did we do, guys? What did we do? Okay, all right. So we then said angle DAC is equal to 90 minus 59, which is equal to 31 degrees. So angle DAC, make yourself see that it's 31 degrees because there's that theorem which talks about angles in a semicircle. Okay, all right. So we know that that's 90, and that plus that should be 90. That 59 plus DAC should be 90 because the total sum of angles in a triangle is 180. Okay, that's why we equated it to 90 minus 59. Okay, so we get 31 degrees there. Okay, next, after calculating DAC, we then calculated angle OAB. which is OAB, okay, which we already calculated as 24 degrees. After doing that, we then calculated angle DAB, okay, DAB, which is 24 plus 31, which is 55 degrees. Okay, that's your angle DAB. Okay. So now that we have angle DAB, we know we can get angle DB tangent reflex. Okay, DB tangent reflex, I labeled this as tangent reflex, okay, because there was no prefix or letter to name it, so I created my own. Okay, so you have to be innovative and creative in mathematics. Okay, so angle DAB is equal to DB tangent reflex. Okay, so we now know that that's the same angle. Okay. And we also know that OB tangent reflex, okay, is equal to 90 degrees because that's the radius and that's a tangent. And because that's 90 degrees, to get our angle OBD, okay, OBD will be 90, which is OB tangent reflex, minus DB tangent reflex, which is 90 minus 55 degrees, and that will give you an answer of 35 degrees. Okay, so make yourself see that will be the answer, and make yourself understand how you apply the theorems. Okay, so you can work out as many questions as you can on circle geometry and circle theorems. Work them out from your textbook, work them out from your past exam papers, and reference with the suggested solutions and answers that you are given. Okay, and keep practicing. Okay, thanks for watching this video, guys, and please like, share, and subscribe to my channel for more educational videos. For one-on-one customized math online lessons, you can contact me on Skype ID kumblani.nwababa, or you can also WhatsApp me on +263 773 002 835. Okay, I hope that you prepare for your examinations, and I wish you all the best. I hope that you pass and you get good grades, A grades or B grades or A+ grades. Okay, and please feel free to hit me up. These videos are to help you understand mathematics. Okay, some say mathematics is very challenging. Okay, but if I can do it, you can do it. Okay, and I'm there for you guys. Feel free to hit me up, and please, guys, spread your energies, study all your subjects. Okay, and I'm available for you online anytime. You can hit me up, guys, and then we can get to business. The world is going online, okay, so we have to make the best of this. We have to start getting used to learning things through videos, learning through online tutorials. Okay, guys, and wherever you are, whichever part of the globe that you are, I'm ready to help you. Okay, happy studying, guys. Cheers.